Hey, you clever little cupcakes! Today we're going to be working on examples of titration stoichiometry. So to get us started, we're going to get a question up here. So we have 50 mils of hydrochloric acid, and it is at an unknown concentration. They are unknown. It's what we're going to be solving for here today. But we do have some 0.1 molar sodium hydroxide. Yeah, I know, super vanilla titration, but it's one that most of you should be familiar with. So we fill our burette up with this sodium hydroxide, and the initial volume of the burette is going to be 73.25 mils. And we go ahead, we do our little titration, we do our drip in the end, and we get to the very end, and the final volume, when we get that beautiful rose color, and I know that you can all do titration spectacularly, is 12.65 mils. This question would then say, solve the concentration of the hydrochloric acid. All right, we have everything that we need. To get us started, we need our actual volume of base used. You see, our burette started off at a volume of 73.25 and it ended at 12.65, but we need that actual volume. So our volume is going to equal 73.25 subtract 12.65, which equals 60.6 milliliters. Now, be very aware, although stoichiometry and titrations typically uses milliliters, when we start filling this into our equations, we're going to need this in liters. So let's put this in liters. Put in liters, you divide it by 1,000, it's going to equal 0.0606 liters. And that's the value that we're going to use for our next step. Well, let's just scroll this up and we'll keep our volume right there on the screen, because step one, get moles of base. We know the volume of sodium hydroxide that we used. We know the concentration of the sodium hydroxide that we used, but to do stoichiometry, we need moles. We're going to use the equation C equals N over V. We know the concentration. It's 0.1. We don't know N. That's our moles. We're going to divide this by our volume in liters. We got it in liters. Don't forget that. 0.0606. To get this N all by itself, we're going to multiply both sides by the 0.0606. We're going to get that our number of moles is 0.00606 moles of sodium hydroxide. Step one complete. Time for step two. In step two, we are going to convert 2 moles of acid. Now keep in mind that if someone titrated acid into base, these would have to be reversed, but we're doing base into acid. So convert 2 moles of acid, and we can write out our balanced chemical equation for this titration, because it was HCl plus NaOH produced H2O plus NaCl. And hopefully everyone out there already knew that hydrochloric acid and sodium hydroxide react in a 1-to-1 ratio, which means if I convert moles of sodium hydroxide into moles of hydrochloric acid, it's going to be 1-to-1, but I'm going to show my work. 0.00606 moles of NaOH multiply by the coefficient of what you want, 1 HCl divided by, you divide by the coefficient of what you're trying to get rid of, 1 NaOH. This is going to equal 0.00606 moles of HCl. Almost done. One more step. In our final step, and we'll just keep that up on the screen there, for step 3, get concentration of our acid. We want to get the concentration of our acid. We are going to use the exact same equation we used in step 1 all over again. C equals N over V. Our concentration is going to be unknown. Our number of moles, 0.00606. We would have to check back to the beginning to figure out what volume of hydrochloric acid we used. It was 50 mils. Do not forget that that has to be divided by 1,000. That volume always has to be in liters. We divide this out, we are going to get that our final concentration is going to equal 0.1212 moles per liter, and that is our concentration of HCl, 0.1212 molar. And just like that, we've been able to do a titration problem that involves stoichiometry. Thank you very much for watching. I hope that the video was helpful, and I hope to see you next time.